Hi children, a warm welcome to 9th class physical science digital lessons. Today we are going to discuss about the atoms and molecules part 1. So, it is very important topic because it is the fundamental basic of chemistry. To know about the intermediate chemistry or degree chemistry or further anyone. So, it is very important topic. So, that is why today we are going to discuss about the atoms and molecules part 1. So, before atoms and molecules, we know that matter means what? Matter is anything that has a mass and occupy the space. So, whatever it may be, sir, matter is anything that having mass and occupy the space. That may be laptop or that may be chalk piece, that may be duster or that may be blackboard, whatever it may be, sir. So, if you have to consider any object as a matter, that it must be satisfy two things. One is must be mass and another one is it must be occupy the space, that is volume. So, it is very important point, sir. So, in that matter only atoms are exist. So, matter is nothing but it is a discrete particles of atoms, means indivisible particles of atoms. So, we notice that on burning charcoal it leaves ash at the end of the chemical change. So, earlier the scientists thought that the mass of charcoal decreases when charcoal is burnt, means during the chemical change, but Antoine Lavoisier carried out a burning of charcoal in a closed container. Then he observed that there is no change in a mass. So, from that he proposed a one law. That law is known as law of conservation of mass. That law of conservation of mass was proposed by Antoine Lavoisier and he also known as father of modern chemistry. That law of conservation of mass states that matter is neither be created nor destroyed during a chemical reaction. Means mass is neither be created nor destroyed during a chemical reaction. That means what? The mass of the reactant is equal to the mass of the product during a chemical reaction. So, what do you mean by here reactant and what do you mean by here products? Means the chemical substances which are participate in a chemical reaction are known as reactants, and the new chemical substances which are formed or which are produced during the chemical reaction are known as products, sir. So, Antoine Lavoisier conducted here one lab activity to explain the law of conservation of mass. To conduct the lab activity here 5 important things are required. First one is aim, second one is materials, what materials are required, and third one is procedure, and fourth one is observation, and fifth one is results, sir. So, first one is what? Aim. So, what is our aim? To prove the law of conservation of mass, means change in a mass before the reaction and after the reaction. So, second one is materials required. So, what materials are required? Here lead nitrate, potassium iodide, distilled water, 2 conical flask, spring balance, small test tube, retard stand, rubber cork and thread, etc. sir. These materials are required. Okay, now procedure. How we can conduct this lab activity? So, first of all we have to prepare silver nitrate solution. Prepare a solution of lead nitrate by dissolving approximately 2 grams of lead nitrate in 100 ml of distilled water in a 250 ml conical flask. Then prepare a potassium iodide solution by dissolving approximately 2 grams of potassium iodide in 100 ml of water in another conical flask. Then take 4 ml of potassium iodide solution in a small test tube from the prepared solution. Next step, hang the test tube containing 4 ml of potassium iodide solution in the conical flask containing lead nitrate solution carefully without mixing the solutions. Then close the flask with a rubber cork, and next step, weigh the flask with its contents carefully using spring balance. Now note down observation means how much reading is come out. Mix the two solutions, one is potassium iodide solution and another one is silver nitrate solution. If we mix the potassium iodide solution and silver nitrate solution, then we get white precipitate. That white precipitate is known as products, and that white precipitate contains two types of chemical compounds. One is silver nitrate, one product, and another one is potassium iodide. So now weigh the flask again using the same spring balance and note down the reading how much weight is result out. Now you observe that the weight of flask and contents before mixing and weight of flask and contents after mixing both are equal. Then from this experiment we can say that a chemical reaction takes place and the mass remains same before and after the chemical reaction. So from this lab activity, Antoine Lavoisier concluded that mass is neither be created nor destroyed during a chemical change. Chemical change means chemical reaction, whether the reactants are converted into the products. And next important topic is law of constant proportions. Law of constant proportions was proposed by Joseph L. Proust, and this law of constant proportions states that a given chemical substance always contains the same elements combined in a fixed proportion by a mass. So for example, water is there. So many sources are there for water. For example, lake water is there, ponds water is there, municipal water is there, tap water is there, sea water is there. All these waters molecular formula is remain same, that is H2O. So in all kind of source of water, two hydrogen atoms are there and one oxygen atom is there. So what is the atomic mass of hydrogen? Atomic mass of hydrogen is 1 AMU. So here two hydrogen atoms are there. So that's why the atomic mass of two hydrogen atoms here 2, and atomic mass of oxygen is 16. So what is the ratio of here two hydrogen atoms and oxygen is 2:16. That means 1:8. In 1:8 ratio, these hydrogen and oxygen atoms are present in all sources of water. And Proust took two samples of copper carbonate. This copper carbonate compound contains three kind of elements. One is copper, second one is carbon, and third one is oxygen. He took copper carbonate sample from nature and another sample prepared in lab. That means prepared in lab means that is a synthetic compound. So this synthetic compound and nature compound both are containing what? Copper, carbon and oxygen. So now you observe one table here. So first column is element. In that element copper is there, carbon and oxygen. Next column weight percentage. So in weight percentage two kind of samples are there. One is natural sample and another one is synthetic sample. Copper. In natural sample weight percentage is 51.35 and in synthetic sample copper weight percentage is 51.35. That means what? The weight percentage of copper is remains same in both type of sample, that is natural sample and another one is synthetic sample. In a same way carbon, the weight percentage of carbon is in natural sample 38.91 and in synthetic sample 38.91. That means what? The weight percentage of carbon is remains same in natural sample and in synthetic sample. And in a same way the weight percentage of oxygen also similar in natural sample and synthetic sample, that is 9.74. So from that he concluded that the relative proportion of elements in a compound is independent of the source or methods of preparation. It is about the law of constant proportions. So already we discussed about the matter. So this concept of matter was explained by the John Dalton. So on the basis of theory he explained that the nature of matter. So he proposed, John Dalton proposed a theory. That theory is known as Dalton's atomic theory, and this theory was a landmark in the history of chemistry, and he proposed some important points. That important points are known as postulates of Dalton's atomic theory. So according to him, matter consists of indivisible particles called atoms. That means actually atom, the word atom is derived from the Greek word. The word atom is derived from the Greek word. In Greek, atom means indivisible or uncuttable. Indivisible or uncuttable. That means what? Which cannot be further subdivided. Which cannot be further subdivided. So, according to him, atom is uncuttable part of the matter which can takes part in a chemical reaction. Which can be takes part in a chemical reaction. And he explained that atom is neither be created nor be destroyed. Atom is neither be created nor be destroyed during a chemical change, because according to the law of conservation of mass, mass is neither be created nor destroyed. That is why atoms are neither be created nor destroyed. Third point, all the atoms of same elements have identical mass, identical size and identical chemical properties, and atoms of different elements have different masses, different sizes and different in chemical properties. And next important point, compounds are formed when atoms of different elements are combined in a simple whole number ratios. When atoms of different elements combined in different whole number of ratios, they forms different types of compounds. For example, carbon and oxygen. When carbon and oxygen combined with each other, then they forms two types of compounds. One is carbon monoxide and its formula is CO, and another chemical compound carbon dioxide and its formula is CO2. So, in both type of compounds, same elements are there, one is carbon and another one is oxygen. So, if supposed to be carbon and oxygen both are combined in 1:1 ratio, then it forms carbon monoxide, that is CO. If supposed to be carbon and oxygen combined in 1:2 ratio, then it forms carbon dioxide, that is CO2. So, at the same time of John Dalton, our Indian ancient also discuss about the atoms and molecules. About 2600 years ago, an Indian sage called Kannada postulated atoms in his Vaisheshika Sutra. According to him, all forms of matters are composed of very small particles known as anu, and each anu may be made up of still smaller particles called paramanu. So, we know that the substances are made up of atoms or molecules. Atoms are the most fundamental of all particles that can have an independent exist. So, two or more atoms are combined together and forms what? Big particle. That big particle is known as molecules. And we know that matter is chemically classified into two types. One is pure substances and another one is impure substances. So, pure substances are again classified into two types. What are they? One is element and another one is compounds. So, elements means what? Elements are the pure substances which are composed by only one kind of atom. Elements are the pure substances which are composed by only one kind of atom, and these elements are cannot be further subdivided during the chemical change. So, atoms of the same elements are combined with each other forms molecule, and atoms of the different elements are combined with each other and forms compounds. Means if similar elements, atoms of the similar elements are combined with each other, then it forms what? Molecule, and if atoms of the different elements are combined with each other, then forms compounds. So, elements with more than one atom in their molecule. We have learned that several elements have more than one atom in their smaller constituent particles. These elements contains two or more atoms combined together to form a molecule. That is, examples oxygen, hydrogen, nitrogen, chlorine, ozone, like that. So, here oxygen is there. Oxygen element is combined with the two O atoms, means two oxygen atoms. In the same way, hydrogen is there. Hydrogen element is combined by the two hydrogen atoms. Nitrogen is there. Nitrogen element is combination of two nitrogen atoms. That means oxygen element is represented by O2 molecule and hydrogen is there, hydrogen is represented as H2 molecule, and nitrogen is there, nitrogen is represented as a N2 molecule, and ozone is there, ozone is represented as O3. So, how we can write the formula of oxygen molecule, or how we can write the formula of nitrogen molecule means, so here oxygen molecule, 2 oxygen atoms are there. So, then why don't we write it as a 2O? Because if we write as a 2O, then it indicates 2 separate oxygen atoms. Then it indicates what? 2 separate oxygen atoms. That is why we have to write O2. In which manner means, first of all we have to write the symbol of oxygen atom. The symbol of oxygen atom is O. Then we have to write the numerical number as a subscript. So, in case of oxygen, how many oxygen atoms are there? 2. That is why its numerical number is 2. So, numerical number is 2. We have to write as a 2 as a subscript. So, that is why the symbol of oxygen molecule is O2. So, here subscript number indicates number of atoms of oxygen combined to form its molecule. You might have heard about ozone gas. This gas is found in large quantities in the upper layers of the Earth's atmosphere. So, upper layer means which one? Stratosphere. So, ozone gas is mostly observed in stratosphere. So, it protects us by shielding the Earth from harmful ultraviolet rays of the sun. Every molecule of ozone has 3 atoms of oxygen. So, can you write the formula of ozone? So, in ozone how many oxygen atoms are there? 3 oxygen atoms are there. So, that is why first of all we have to write the symbol of oxygen atom. So, symbol of oxygen atom is O. Then how many number of oxygen atoms are there? 3. So, that is why we have to write 3 as a subscript after symbol. So, it is written as O3. Then some examples of molecules. Nitrogen molecule is there. So, nitrogen molecule formula is N2. Hydrogen molecule formula is H2. Chlorine molecule formula is Cl2. Fluorine molecule is there. Fluorine molecule symbol is F2. Next one, it is very important to understand, to learn the chemistry. So, symbol of elements. Why symbols are required? Why we have to give the names for the elements? At that time, now at present, how many elements are there means 118 elements were discovered, sir. How many elements are discovered? 118 elements are discovered. So, these 118 elements are discovered. So, we have to remember all these names and all these symbols. So, how we can remember? In our world, so many languages are there. Why do we name elements? There are so many languages in the world that it is not possible to know the different names of each element in different language. So, to help the scientist or to help to communicate the scientist without confusion in between the 2 different countries or in between various countries, we must have one name for each element that is accepted by everyone. So, John Berzelius suggested that initial letter of an element from its name in English written in capitals should be the symbol of that element. For example, oxygen is there. In oxygen, initial letter is O. That is why the symbol of oxygen is O. O is the symbol of oxygen atom. Similarly, hydrogen element is there. In hydrogen element, initial letter is H. That is why the symbol of hydrogen element is H. So, how we can write the symbol of elements are here means, first of all, a symbol can have either 1 or 2 letters of English. A symbol can have either 1 letter or 2 letters of English. In that, first letter must be capital and second letter must be small letter. So, here table is given that symbols for some element. Here in first column element name is there and in second column symbol is there. So, hydrogen is there, element name hydrogen and symbol of hydrogen is H. And next one, element name is oxygen and its symbol is O. Next element nitrogen and its symbol is N. Next element sulfur and its symbol is S. Next element carbon and its symbol is C. Next element calcium, its symbol is Ca. You see here, in case of Ca, C is capital letter and A is small letter. So, If the symbol is 2 letters, then must be first letter capital and second letter must be small. And next one, chlorine element is there. So, symbol of chlorine is Cl, C is capital and L is small letter. And next one, chromium. Chromium symbol is Cr. Boron, boron symbol is B. Barium, barium symbol is Ba. Bromine, symbol is Br. Beryllium, symbol is Be. Aluminium, aluminium symbol is Al. Iron, iron symbol is Fe. Gold symbol is Au. Sodium, sodium symbol is Na. Potassium symbol is K. You see here last 4 elements iron, gold, potassium and sodium. These 4 elements are having different symbols. You observe here iron, actually in iron first letter is I, that means its symbol must be I, but here symbol is Fe. In case of gold, first letter is initial letter is G, but here symbol is Au. Why? Because few of the elements are there. Out of 118 elements, few elements are there. These few elements are having Latin names. On the basis of Latin names, these elements are having different symbols. For example, sodium is there. Actually, it is a common name. Sodium is a. Actually, its Latin name is natrium. That's why its symbol is Na. You observe here, some elements come from their names, but some don't. Certain elements have symbols based on their Latin names, that is older names. So, you see here 3 horizontal lines are there. One is element name, second one is Latin name and third one is symbol name. So, first element is sodium. It is a common name, sir. So, sodium is there. Actually, the Latin name of sodium means older name of sodium is natrium. So, in natrium, first initial letter is N and second letter is A. So, the symbol of sodium is Na. In a same way, silver. Silver Latin name is argentum and its symbol is Ag. And next element tungsten. Tungsten Latin name is wolfram and its symbol is W. Next element is potassium. Potassium Latin name is kalium and its symbol is K. And next element copper and its Latin name is cuprum and its symbol is Cu. And next element is gold and the Latin name of gold is aurum and its symbol is Au. And next element is iron. Iron Latin name is ferrum and its symbol is Fe. Next element is lead. Latin name is plumbum and its symbol is Pb. And next element is mercury and mercury Latin name is hydrargyrum and its symbol is Hg. Now, in this class we discussed about the law of conservation of mass and law of constant proportions and what is atom, what is molecule and symbol of elements. So, in this session we discussed about the atoms and molecules part 1 topic. So, in this topic we discussed about law of conservation of mass, law of constant proportions and symbols of elements, Dalton's atomic theory. So, today we discussed about the atoms and molecules part 1. In that we will see in next session. For better knowledge or for better understanding of the concept, solve the worksheets, please visit the official website of SCERT. Thank you.